looking at the workshop. Very frustrating, very frustrating. I spent a lot of time trying to see if I can get the project to work with regenerating it so we can add the new IP that we create in the workshop that does edge detection. So far, I haven't. I'm getting close, but I am not there yet. I'm running into issue with one of the IPs. What I'm trying to do is get it to take the modification that I made that I think will fix it. Because I think I know what it's looking for, but whenever I run it, it's not finding it. I've tried, one of the recommendations when I looked on the web from Digilent was to use the standard Xilinx IPs, and I haven't had much success with that either. Getting the right combination, trying to get reference design to try and figure out how you connect everything in. I was hoping I'd just be able to pull out the Digilent ones and put in the Xilinx one, and a little bit more complicated than I thought. So I decided to see if I can get the original code working. I was able to generate the new IP and get that inserted. The issue I ran into with that, which was rather interesting, is it kept looking for, I put it in there, it kept looking for a DSP file, which I believe has to, from what I read, has to do with the fact, the type of IP it is. That it uses memory, I think it slices, so it wants a DSP because that makes it perform better rather than using the straight code. I have to learn more about that. Basically, what I had to do to go in and to be able to find the DSP files, I had to go in. Let me show you something here. Let's go. Oh yeah, we are in the right, correct screen, I think. Let me see if I can find what I'm looking for. So this is, here we go. So let me see, this is a little small right now. Let me make it bigger. This is the IP I've been having issues with that does not want to cooperate. It refuses, it keeps complaining every time I try to build it, saying that it, see, we can actually see the errors. Let's see if I can, why are you not, should be able to do, here we go. Messages. So it's, if you look at the code, what's happening is it's trying to find this in here. This is your port. This is, and what's complaining is that, let's see if I can find the actual error. No port access data count on instance. So this is, it's failing here because it doesn't have a version of access data count. And if you look here, it doesn't, you don't see it. Now, what I tried doing is adding it in. So far, it's not taking it. So that's the issue I'm still working on. The other thing is, here is our new IP. And it could, this design that is the latest, I think it was just put out last week, this version of PCAM. It is not exactly like the one that they describe in the workbook. So you have this design. Let's blow it up so we can see it better. Edge detect. Edge detect has these inputs and outputs, the input is not exactly what they were telling you. It now goes, because I guess they've put a memory AXI VDMA. That's what I hooked it up to, and it seems happy with that. They go through it. Now, when I brought this in here, it initially would complain. Let's see if I can find IP sources. Yeah. Let's see if I can find it. Here. It was initially complaining it couldn't find anything. What I did is I repackaged it and brought it back in, and now it seems as happy as a little clam. So that's good. Doesn't solve the problem with MIPI CSI2, the receiving. MIPI, by the way, is mobile, related to mobile. Let me see if I can find what I had brought up here. So anyway, it's related to mobile, and you can look it up. Let me see if I can. I'm going to pull up the definition, and I'll like. Mobile Industry Processor Interface. So there's an organization that is trying to standardize the mobile interface, mobile industry processors. So make the interface that's being used standard. And this is supposedly using this one that's been problematic. Where'd it go? I have to shrink it down here a little bit. Now bring it here. Here it is. Here is the one that's been complaining. So this is your MIPI CSI 2RX0. This is the one that it is not happy because it cannot find the port. And if you look at the code, you can see there is no M access data count in the port in the definition of the LLP entity. So I tried putting it in, and so far it's not taking it. It's not keeping it. I'll put it in there, and I've tried repackaging, and I still don't. When it tries to find it, it doesn't see it. So that is, I think, the problem. And what I'm trying, because you can see down here in line, it's a line buffer. In here, and it defines these ports that match the actual. Let's define these components. So define the line buffer component that has access data count. When you go down to line 5, well, first let's look at line 111. Again, that's where it's defined. When it goes here to line 578, now this is Digilent's code, by the way. You can see it does use it. It does not set it to a port. It sets it to a signal. MBUF data count is a signal. But it's the apparently. Where is it? Apparently, MIPI CS2 RXVHD 77. Let's see if I can even get that to come up. Here we go. Apparently, it wants that access data count port. Well, that's interesting. It does not even define it. Let's have a look here. Huh. I'm actually a little confused here. So let's look. Let's see. 112. And my guess is it's in here somewhere. Access data count. So here are all our ports. No? Let's see in here. See if I can get this one open. Here we go. 131. So this is So it's saying no port access data count failed. So it goes right to 112. And stream signal, video, clock. Oh, this is very interesting. I'm wondering if another approach is just commenting out access data count and seeing if it complains. So it's complaining here that it says it's no port access data count on instance. So it's complaining it doesn't have this. I'm wondering if this has to do with maybe a line LLP. So this is component LLP, and it's not defining access data count in here. I'm wondering if that, but anyway, so you can see there is some issue in the code here that they apparently think they resolved, and for some reason I have not been able to and that's another interesting thing. I have to work on this. At any rate, let's have a look at the actual high-level synthesis. I think that's, yeah, here it is. So this is our HLS, and I went through the same things that I did previously that we've seen on the very simple example, but this takes advantage of libraries that are already provided. The edge detection algorithm that it's concerned about is the Sobel algorithm, which does the edge detection, and it has to do with matrices, and basically it's finding the distance, and if it's a big distance, then we know we have an edge. And that's what the Sobel algorithm does. That's the key thing here. So what it does is it converts color to grayscale. It pulls the frame, converts it to grayscale, runs this edge detection, turns it back to color, and sends it out. So that's how this edge detection works. And what it's going to do is it's going to produce, when you run through here, then it is going to produce the zip file. I believe that's what I did. Now I use solution 2. But the difference between the solutions, as we mentioned, I think we mentioned about solutions in HLS. We mentioned the fact that they have different directives, and it changes the performance. Like solution 2 here has, if you look at the directives, let's see if I can get it. Oh, come on. I want to see directives. Here we go. So that looks like the directive. Okay. Let's see if I can get the directives up. View. Directives. Let's see. Well, it adds additional directives, and those things impact, it adds data flows. It impacts how, remember I mentioned the speed versus resources trade-off that you have when you're programming a FPGA. And what we do here with the directives is it can improve or reduce the performance. So what we do here is they have you add in, I believe, the HLS interface and HLS data flow, and speed versus resources used. So if you have faster, you need more resources on the FPGA. So anyway, we go through this, and like I mentioned, what we had to do here is go into the packager. Let me see. I'm going to have to bring that up because I do not have the let me bring that up and show it to you, because this is actually something that you might be using, and I will probably have to use if I intend to fix that the MIPI CSI receiver. So we will see about that, but I'm going to bring it up, and once it comes up I will show it to you. I will create a, here it is. Okay. So let's add that plus and let's see. I think. Oh, yes. Okay. So this is the packager. This allows you to edit and repackage IPs. And what I had to do in this case is repackage it so it would find all the pieces and parts it needed. Another use, I'm gonna close this, and I will probably go to a, yeah. So what I'm gonna do here is, let's go back here. I'm going to show you what I'm going to attempt to do with the edit an IP is what I'm going to start looking at in the packager. Let's see if I have to bring the packager up. That would be perfect. All right, so the packager here, what I can do is look at all this code that's been complaining, like this, and it's complaining about something that I don't quite understand. It's saying here, again, so if you're familiar with Eclipse, you're going to be actual performance port is neither a static name or a globally static expression. Well, since this was in the original code, I am just going to basically ignore it and see if it complains when I actually package it. And what I'm going to do, I think the next thing to try is just see if I can get rid of access data count altogether and see if that matters, because if you look at it, let's see. Okay. So if we go to here, is it actually even used? So that would, let's see what's happening. Next. So this is used. So I can't just get rid of it, because apparently it is necessary. So I'm going to have to figure out a way, maybe adding it into the other, I think going the other way, adding it into the other, the higher level codes of calling this. So we've got all different, I have to find which ones, what file I need to update in here and take care of that and see if that fixes it. So that's what we're going to see. So anyway, limited success this week. If you have solved this problem and you're watching this, please leave a comment. Tell me if you see what I'm doing wrong. I'm not an experienced VHDL or Verilog programmer. I'm not, I'm just learning this stuff myself. I'm an experienced programmer. I've been doing in the IT industry for years. The last eight of which has been mostly Java development. So I'm pretty comfortable with code. The concept of the FPGA is something I'm still trying to wrap my head around totally. But at any rate, so that's where we are. I'm hoping I could get it running and show that edge detection. What I also want to do is figure out, okay, Digilent, have your own libraries here to do image processing. Should I use those? Xilinx has IPs, and is there an example design? I haven't found a good example. I actually tried using the reference design from that's in the Xilinx IP, and it didn't like that. So I could not get that to work. And plus, the reference design, I was hoping I can get it to come up and then use that as a basis of putting something together. But that didn't work. So anyway, I hope this has been informative. I hope I have at least shown you some of the issues I ran into. And so if you try to go through this workshop with your Zybo Z7 10 or 20, you'll know some of the gotchas that I found. And like I said, if you've solved this, if you've gotten this thing to work, because here's the thing that you have to understand about Vivaldo and the the Xilinx FPGAs, and I imagine it's the same for the Altera Intel FPGAs. The code is very version based. So every quarter they put out a new version of an update to Vivaldo. Code that worked on a previous version, IP that worked on a previous version may not work on the new version. And that is an issue that you have to be aware of if you're using this. Because you are so close to the hardware, it's a little, changes a lot more than, if you're writing straight, if you're writing for a regular, regular code, let's say web, or you're writing even for a microprocessor, you're writing your Arduino code, or you're writing for Arduino in C or CircuitPython, or even there's a gentleman who's putting in a lot of effort, doing an excellent job introducing people to the nano encoding for AI with the NVIDIA Nano Jetson, and he's doing it in Python, and that stuff just does not change that much. When you put, I've used dozens of versions of Eclipse. If I take a new version of Eclipse, it usually doesn't have an effect on my code. But Vivaldo, FPGA is a whole nother ballgame. So, okay, so I will see you next time, and thank you, and speak to you soon.